A headline is circulating right now claiming Yellowstone's supervolcano has finally erupted and that hundreds of earthquakes are hitting the region. Before going any further, here is the direct answer, checked against the actual official monitoring data, available as this is being written. Yellowstone has not erupted. There is no eruption in progress, no lava flow, no ash cloud, and no evacuation order. The United States Geological Survey, the government agency responsible for monitoring the volcano around the clock, currently lists Yellowstone's alert level as normal, with the aviation color code set to green, the lowest, calmest classification on their entire scale. This kind of claim tends to spread in a very specific, recognizable pattern online. A real small piece of Yellowstone news, a minor earthquake swarm, a routine monthly seismic report, a small hydrothermal explosion, gets picked up, stripped of context, and rewritten with maximum drama attached, often within hours of the original, far more measured scientific update being published. By the time it reaches a viral headline, the actual numbers involved have usually been wildly inflated, and the routine, expected nature of the underlying activity has been quietly dropped entirely. So, where did this particular claim come from? Why does it keep resurfacing every few months in slightly different wording? And what is actually happening underground at Yellowstone right now that might explain the confusion? That is a genuinely interesting story on its own, and it does not require inventing an eruption that never happened. Let's start with the earthquakes, since that part of the claim contains a kernel of real, verifiable activity, just badly exaggerated. Yellowstone is, in fact, one of the most seismically active regions in the United States, and it experiences earthquakes constantly, all year, every year, as a completely normal feature of the landscape, rather than a warning sign of anything unusual. According to the Yellowstone Volcano Observatory's own monthly reports, the region typically sees somewhere between 1,500 and 2,500 earthquakes in a normal year, an average that works out to roughly 4 to 7 earthquakes on a completely ordinary day. The overwhelming majority of them far too small to be felt by anyone at the surface. In July 2026 alone, the most recent full month with confirmed official data, the University of Utah Seismograph Stations, which operates the Yellowstone Seismic Network on behalf of the observatory, located 68 separate earthquakes in the park. The largest of those was a magnitude 3.3 event, strong enough to be felt by some visitors in the immediate area, but nowhere close to the scale of earthquake that would indicate rising magma or an approaching eruption. Earlier in the year, April saw 97 recorded earthquakes, including a swarm of 16 quakes clustered together over 2 days near Mammoth Hot Springs, and February saw a comparable swarm of 12 quakes near West Yellowstone. None of this is unusual. Earthquake swarms, clusters of many small quakes happening close together in time and location, are actually one of the most common and well-understood phenomena at Yellowstone, generally caused by fluid movement along existing underground fractures rather than fresh magma pushing toward the surface. In fact, one of the best real-world examples proving this point happened back in 2017, when a swarm near Maple Creek in Norway. Yellowstone produced more than 2,400 earthquakes over a span of about 3 months, making it one of the largest swarms ever recorded at the park. The USGS response to that swarm at the time was to make no change whatsoever to the alert level, because their scientists determined the activity was consistent with fluids shifting through pre-existing cracks in the rock, not new magma intrusion. If a swarm of that size, more than 30 times larger than the entire month of July 2026 activity, did no raise the alert level in 2017, a comparatively modest 68 earthquakes in a single recent month clearly does not represent evidence of an imminent eruption either. This comparison matters because it gives a genuine sense of scale. Viral claims about earthquake activity almost never provide that kind of context, leaving a reader with no way to judge whether a given number is actually alarming, or, as is almost always the case at Yellowstone, well within the range the park experiences during any ordinary season of the year. So what would it actually look like if Yellowstone genuinely were building toward an eruption, and how confident can scientists really be that they would catch it happening? This turns out to be one of the more reassuring parts of the whole story because Yellowstone is arguably the single most closely monitored volcanic system on the planet. The observatory currently operates a network of roughly 46 seismometers scattered across the region, alongside around 26 continuous GPS stations that measure ground movement with extraordinary precision, some of them capable of detecting surface shifts as small as a few millimeters, far finer than anything a person standing on the ground could ever notice with their own senses. Multiple satellite passes collect additional deformation data every single day, cross-checking the ground-based instruments from orbit and building an increasingly detailed, continuously updated picture of exactly what the entire caldera is doing at any given moment. According to volcanologists who study the system closely, a genuine eruption precursor would look dramatically different from anything currently being recorded. Scientists would expect to see earthquake magnitudes escalating steadily over a period of months, not sudden isolated spikes, followed by a return to background levels. They would expect sustained ground uplift measured in meters, not the mere centimeter or two of subtle seasonal movement currently being tracked. They would expect persistent harmonic tremor, a specific, continuous seismic signal associated with actively moving magma, distinct from the sharp, individual jolts of an ordinary tectonic earthquake, and significant, measurable changes in the gas. Chemistry escaping from the park's geothermal features, since magma rising toward the surface tends to release detectable shifts in gases like sulfur dioxide and carbon dioxide well before anything visible happens above ground. None of those specific warning signs are currently present in the data. Given the density of the monitoring network in place today, scientists studying the system say they would likely have hours of advance warning before any actual eruption, not hours or days, which is precisely why the current normal alert level genuinely reflects the underlying science rather than downplaying some hidden danger. None of this means absolutely nothing interesting has been happening at Yellowstone lately, and this is really where the genuinely fascinating, entirely real story sits, buried underneath the false eruption headline. Starting in July 2025, GPS instruments detected a bulge forming along the northern rim of the Yellowstone caldera, an area roughly 19 miles across that gradually rose by about 1 inch over roughly 7 months. Scientists monitoring the deformation believe this kind of swelling is most likely caused by magma shifting around roughly 9 miles below the surface, a genuinely normal, well-documented process at Yellowstone that has happened many times before without leading anywhere close to an eruption, the caldera essentially rising and falling in slow, multi-year cycles that researchers sometimes describe informally as the ground breathing. According to the most recent official monthly updates, that specific uplift along the North Caldera Rim actually stopped by mid-January 2026, and deformation across the wider caldera since then has been described by USGS scientists as showing no significant uplift or subsidence, essentially sitting still or moving so slightly that scientists attribute the tiny remaining fluctuations to ordinary seasonal changes in underground water levels rather than anything volcanic at all. In fact, some of the ambiguous readings recorded during the winter months were later explained simply by heavy snow interfering with the GPS equipment itself, a mundane technical hiccup rather than anything geologically significant. There has also been a genuinely newsworthy piece of hydrothermal activity worth mentioning honestly, because it likely helped fuel some of the recent viral confusion. On June 13, 2026, a small hydrothermal explosion occurred at a site called Biscuit Basin, not far from a similar, slightly larger explosion that had previously occurred at the same general area back in 2024. Hydrothermal explosions are a completely different phenomenon from a magmatic volcanic eruption, and it is important not to blur the two together the way some sensational headlines tend to. A hydrothermal explosion happens when underground water, heated by the geothermal system, flashes suddenly into steam and blasts through the surface, throwing rock, mud, and boiling water outward, sometimes creating a new small crater or pool in the process, occasionally even carving out a brand new thermal feature where none existed the day before. It is driven by shallow water and heat dynamics, not by magma actually erupting from deep within the earth. And while these events can be genuinely dangerous to anyone standing too close, they are a well-known, regularly occurring feature of Yellowstone's geothermal landscape, not a sign of the supervolcano itself waking up. Following the June explosion, the observatory installed a new monitoring camera at the site in July, giving scientists a continuous view of both the new explosion feature and the older 2024 site for ongoing observation, exactly the kind of careful, unglamorous scientific follow-up that rarely makes for an exciting headline but represents how the system is actually being studied and managed. Researchers are also in the process of installing an additional seismic and infrasound monitoring station nearby, expected to come online later this year, further expanding the already dense network watching over exactly this kind of shallow hydrothermal activity. Beyond the ground itself, Yellowstone's famous geysers have also had a genuinely eventful year, offering their own dose of real excitement without needing any exaggeration attached. Steamboat Geyser, the tallest active geyser in the world, capable of shooting water higher than 300 feet into the air during a major eruption, went through a notably active stretch in early 2026, a pattern of behavior that has fluctuated considerably over the years, from as many as 48 eruptions in a single year to as few as 8, without any of those swings ever being connected to volcanic risk. And Equinus Geyser, in the park's Norris Geyser Basin, reawakened in February 2026 after several years of dormancy, erupting roughly 40 times that month alone, its first activity since 2020, before settling back down to only a handful of eruptions in the months that followed. These kinds of geyser fluctuations are fascinating, and genuinely worth paying attention to if you follow Yellowstone closely, but they reflect the complex, ever-shifting plumbing of the park's shallow hydrothermal L system. Plumbing that can be affected by mineral deposits, temperature changes, and even nearby earthquakes, altering underground water pathways. Not a signal from the deep magma chamber that the supervolcano itself is stirring toward an eruption. It is worth pausing to ask why headlines like the one that prompted this video keep appearing so regularly, oftentimes suspiciously close to any real, genuine, but comparatively minor news update from the observatory. Part of the answer is straightforward attention economics. Yellowstone carries an enormous amount of built-in dramatic weight in the public imagination, largely because its last truly massive caldera-forming eruption, which occurred roughly 631,000 years ago, produced an amount of ejected material so large it remains one of the most studied volcanic events in Earth's geological record. And popular science coverage over the years has understandably leaned into just how catastrophic a future eruption of similar scale would be. Sometime is illustrated with dramatic maps showing ashfall blanketing much of the central United States. That genuine scientific fact that Yellowstone is capable of an eruption far larger than anything in recorded human history gets combined with completely routine monthly monitoring updates, ordinary earthquake counts, minor hydrothermal explosions, small ground movements, and stitched into headlines, implying those routine events represent evidence the volcano is actively gearing up to repeat that ancient catastrophe. It is a reliable formula for engagement precisely because the underlying long-term risk is genuinely real and genuinely dramatic, even though the actual day-to-day monitoring data almost never supports the specific, urgent framing being applied to it. And because most casual readers have no easy way to check the original, far more measured USGS source documents for themselves before sharing the more exciting version. None of this means concern about Yellowstone is inherently irrational, and it would be dishonest to suggest scientists consider a future eruption impossible. Researchers do take the long-term hazard seriously, and studies published in recent years have explored various scenarios for what a future eruption could look like and how far its effects could reach. In some cases, modeling ashfall extending across large portions of the United States and potential climate effects reaching much of the globe if a full caldera-scale eruption were ever to occur, disrupting agriculture and air travel across an area far larger than the immediate blast zone itself. Geologists studying the volcano's history note that Yellowstone has produced 3 such massive caldera-forming eruptions over roughly the past 2.1 million years, giving an extremely rough, long-term statistical eruption frequency, somewhere in the range of once every 730,000 years. A figure researchers are careful to describe as a loose average across deep geological time, rather than any kind of predictable schedule or countdown clock. That is precisely why the monitoring network exists in the first place, built specifically to catch the earliest possible warning signs of something genuinely building toward that scale, rather than reacting only after the fact. The distinction that actually matters here is not whether Yellowstone could ever erupt. Again, geologically speaking, it almost certainly will at some point in the very long run, but whether current data shows it doing so imminently. And on that specific checkable question, the answer from the scientists actually watching the instruments in real time remains clear and consistent. Background seismicity, no significant deformation, no elevated gas emissions, and an alert level that has stayed at normal throughout this entire period. So to bring this back to the original claim directly, officials have not announced an eruption, because no eruption has occurred. Hundreds of earthquakes have not suddenly struck the region in some dramatic escalation. The actual monthly earthquake counts remain well within the range Yellowstone experiences in an ordinary year. And the observatory's own most recent public update, current as of early August 2026, explicitly describes activity as remaining at background levels. What has genuinely happened is a normal, well-documented year of routine seismicity, a period of gradual ground uplift that already peaked and stopped months ago, a small, non-magmatic hydrothermal explosion consistent with previous events at the same general area, and an unusually lively stretch H for a couple of the park's famous geysers. Every one of those individual facts is true, interesting, and worth knowing. None of them, individually or combined, adds up to a supervolcano eruption. The real Yellowstone story right now is not a catastrophe finally arriving. It is a heavily monitored, well-understood geological system doing what it has quietly done for centuries, breathing, shifting, and occasionally venting steam, while scientists keep watching closely enough that if the real warning signs ever do appear, the world is far more likely to hear about it from careful measurement than from a viral headline. If this helps clear up what is actually happening versus what is just clickbait, alike, helps more people find the accurate version instead of the panic, and subscribing means you will not miss where we go next.